Welcome to MCOM second semester research methodology subject lesson number 37 hypothesis testing in research methodology. I am your teacher Dr. K.V. Somnath, GS College of Commerce, Vartha, Maharashtra. Let us go first of all through some identification of different definitions of or the terms associated with the testing of hypothesis. The statistical hypothesis is nothing but a statement about the parameters describing a population but not a sample. The second one is statistic. A value calculated from a sample without any unknown parameters, often to summarize the sample for comparison purposes. Next one is simple hypothesis. Any hypothesis which specifies the population distribution completely is called as simple hypothesis. Next one is composite hypothesis. Any hypothesis which does not specify the population distribution completely is denoted as composite hypothesis. The next one is null hypothesis, which is shown as H0. A hypothesis associated with a contradiction to a theory one would like to prove. The next one is positive data. Data that enables the investigator to reject a null hypothesis. The next one is alternative hypothesis, which is shown as H1 or HA also. A hypothesis, often composite, associated with a theory one would like to prove is called as alternate hypothesis, which is opposite to null hypothesis. Next one is statistical test. A procedure whose inputs are samples and whose results is hypothesis. The next one is region of acceptance. The set of values of test statistic for which we fail to reject the null hypothesis. The next one is region of rejection or critical region. The set of values of the test statistic for which the null hypothesis is rejected. The next item is critical value. The threshold value delimiting the regions of acceptance and rejection for the test statistics. Generally, we find it in the case of the normal distribution. Next one is power of a test, that is 1 minus beta. The test probability of correctly rejecting the null hypothesis when the alternative hypothesis is true. The complement of the false negative rate beta. The power is termed sensitivity in biostatistics. Next one is size. For simple hypothesis, this is the test probability of incorrectly rejecting the null hypothesis. The next one is significance level of a test, that is alpha. It is the upper bound imposed on the size of a test. Its value is chosen by the statistician prior to looking at the data or choosing any particular test to be used. It is the maximum exposure to erroneously rejecting H0 that they are ready to accept. Testing null hypothesis, that is H0 at significant level. Alpha means testing H0 with a test whose size does not exceed alpha. In most cases, one uses tests whose size is equivalent to the significant level. Next one is p-value. The probability, assuming the null hypothesis is true, of observing a result at least as extreme as the test statistic. It is, in the case of a composite null hypothesis, the worst case probability. Now the statistical significance test. A predecessor to the statistical hypothesis test, an experimental result was said to be statistically significant if a sample was sufficiently inconsistent with the null hypothesis. This was variously considered common sense, a pragmatic heuristic for identifying meaningful experimental results, a convention establishing a threshold of statistical evidence, or a method of drawing conclusions from data. The statistical hypothesis test added mathematical rigor and philosophical consistency to the concept by making the alternative hypothesis explicit. The term is loosely used for the modern version, which is now a part of statistical hypothesis testing. Next one is conservative test. A test is conservative if, when constructed for a given nominal significant value, the true probability of incorrectly rejecting the null hypothesis is never greater than the nominal value. Next one is exact test. A test in which the significance level or critical value can be computed exactly, that is, without any approximation. In some contexts, this term is restricted to tests applied to categorical data and permutation tests, in which computations are carried out by complete enumeration of all the possible outcomes and their probabilities. A statistical hypothesis test compares a test statistics Z or T test, for example, to a threshold. The test statistics is based on optimality. For a fixed level of type 1 error rate, use of these statistics minimizes type 2 error rate, that is equivalent to maximizing power. The following terms describe tests in terms of such optimality. Next one is the most powerful test. For a given size of significant level, the test with the greatest power, that is probability of rejection, for a given value of the parameters being tested contained in the alternative hypothesis. Uniformly most powerful test, UMP, a test with the greatest power for all values of the parameters being tested contained in an alternative hypothesis. Now, hypothesis testing is generally used when we are comparing two or more groups. When we are evaluating a hypothesis, we need to account for both the variability in our sample and how large our sample is. Based on this information, we would like to make an assessment of whether any difference we see are meaningful or if they are likely just due to a chance. This is formally done through a process which is called as hypothesis testing process. There are 5 steps in the hypothesis testing process. The first step is specifying the null hypothesis. Second is specifying the alternative hypothesis. Third one is set the significance level alpha or A. Fourth one, calculate the test statistic and corresponding p-value. And the fifth step is drawing a conclusion. Let us go one by one. First one, step 1, specify the null hypothesis. The null hypothesis H0 is a statement of no effect, relationship, or difference between two or more groups or factors. In research studies, a researcher is usually interpreted in disapproving the null hypothesis. The step 2 is specifying the alternative hypothesis. The alternative hypothesis H1 or HA is a statement that there is an effect or a difference. This is usually the hypothesis the researcher is interested in proving. The alternate hypothesis can be one-sided, only provides one direction, that is lower, or two-sided, maybe lower and upper. We often use two-sided tests even when our true hypothesis is one-sided because it requires more evidence against the null hypothesis to accept the alternate hypothesis. Step 3. Set the significance level A or alpha. The significance level denoted by the Greek letter alpha is generally set as 0.05. This means that there is a chance of 5% that we will accept our alternate hypothesis when our null hypothesis is actually true. The smaller the significance level, the greater the burden of proof needed to reject the null hypothesis, or in other words, to support the alternate hypothesis. Step 4. Calculation of the test statistic and corresponding p-value. Hypothesis testing generally uses a test statistic that compares groups or examines associations between variables. When describing a single sample without establishing relationships between variables, a confidence interval is commonly used. The p-value describes the probability of obtaining a sample statistic as or more extreme by chance alone if our null hypothesis is true. This p-value is determined based on the result of our test statistic. Our conclusions about the hypothesis are based on our p-value and our significance level. P-value is equal to 0.01. This will happen 1 in 100 times by pure chance if our null hypothesis is true, not likely to happen strictly by a chance. The second one is p-value is 0.75, for example. This will happen 75 times in 100 times by pure chance if our null hypothesis is true, very likely to occur strictly by a chance. Now, the cautions about p-values. Our sample size directly impacts our p-value. Large sample sizes produce small p-values even when difference between groups are not meaningful. We should always verify the practical relevance of our results. On the other hand, a sample size that is too small can result in a failure to identify a difference when one truly exists. That's why so many times our research grades tell us as a researcher or research scholar to go for huge large sample sizes. Plan our sample size ahead of time so that we have enough information from our sample to show a meaningful relationship or difference if one exists. See, calculating a sample size for more information, then we will go for finding out the level of P. If we do a large number of tests to evaluate a hypothesis called multiple testing, then we need to control for this in our designation of the significance level or calculation of the p-value. Step 5, drawing a conclusion. P-value if is less than or equivalent to significant level alpha or equivalent or greater than reject our null hypothesis in favor of our alternative hypothesis. This is one condition. Our result is statistically significant. If the p-value is greater than significant level alpha or equivalent or greater than, fail to reject our null hypothesis. This is another condition. Our result is not significantly statistically significant. So that's why when you go for testing of the hypothesis, we need to write sometimes the alternate hypothesis. Then we start the statement of alternate hypothesis that there is a significant difference of, like that, with that particular words we start the rewriting of our alternate hypothesis. Next one is hypothesis testing is not set up so that we can absolutely prove a null hypothesis. Therefore, when we do not find evidence against the null hypothesis, we fail to reject the null hypothesis. When we do not find strong enough evidence against the null hypothesis, we reject the null hypothesis. Our conclusions also translate into a statement about our alternate hypothesis. When presenting the results of hypothesis test, include the descriptive statistics in our conclusions as well. So, report exact p-values rather than a certain range is essential. Now, some of the common tests used in statistics while we go for the testing of hypothesis. That is one sample test. The one sample tests are appropriate when a sample is being compared to the population from hypothesis. The population characteristics are known from theory or are calculated from the population. The second one is two sample tests. The two sample tests are appropriate for comparing two samples, typically experimental and control samples from a scientifically controlled experiment. Third one is periodic tests. These are approach for comparing two samples where it is impossible to control important variables. Rather than comparing two sets, members are paired between samples, so the differences between the members becomes the sample. Typically, the mean of the difference is compared to 0. The common example scenario for which a paired difference test is appropriate is when a single set of test subjects has something applied to them and the test is intended to check for an effect. The next one is jet test. These tests are appropriate for comparing means under stringent conditions regarding normality and a known standard deviation. The next one is t-test. A t-test is appropriate for comparing means under relaxed conditions, that is less is assumed. Next one is tests of proportions and analogs to tests of means, that is when the data is 50% proportion. The next one is chi-square test. The chi-square test use the same calculations and same probability distribution for different applications. Chi-square tests for variance are used to determine whether a normal population has a specified variance. The null hypothesis is that it does. Chi-square tests of independence are used for deciding whether two variables are associated or being independent. The variables are categorical rather than numerical. It can be used to decide whether left-handedness is correct or the height is correct. The null hypothesis is that the variables are independent. The numbers used in calculation are observed and expected as the frequencies of occurring, that is, we can get it from the contingency tables. Next one is chi-squared goodness of fit test are used to determine the adequacy of curves fit to data. The null hypothesis is that the curve is fit to and it is adequate. It is common to determine curve shapes to minimize the mean square error. So, if it is appropriate that the goodness of fit calculation sums the squared errors. F-test, which is also analysis of variance ANOVA, are commonly used when deciding whether groupings of data or category are meaningful enough. If the variance of test scores of the left-handed in a class is much smaller than the variance of the whole class, then it may be useful to study lefties as a group. The null hypothesis is that two variances are the same, so the proposed grouping is not meaningful. I hope you might have gone through how to test and what are the various tests being used for the testing of hypothesis. Thank you all. Stay safe and stay protected. Thank you.